Rapid TCT 2022 is here, and we're kicking things off at the Mosaic booth. You've seen Array, you've seen Element, and we're going to show you something really soon called Stitch. That's just going to blow your mind. There's a lot of really cool stuff here to see as well, and we're going to take you on that journey. Follow me. It's not often at Rapid that you're asked to shake a machine. Is that right, Logan?
That's right.
So, Pantheon Design, we've talked before in email, sometimes it fell through. We finally met up here at Rapid, and they are just north of me in British Columbia.
Yeah, we're just above you in Vancouver.
This is your amazing machine. So what strikes me is the speed at which this thing is printing.
Yes.
How is this possible at accuracy?
So the whole design philosophy was speed and reliability, and to achieve that we put servo motors on, we put ball screws on, we did away with all the belts. Everything is machined. There's no plastic parts taking any force on the machine. And that's how we're able to achieve print speeds at 400 millimeters per second and travels at 1 meter per second.
1 meter.
1 meter per second.
Meter per second for a travel.
And
now,
1 G acceleration, so we're almost always at top speed. Yes.
Jeez, okay. I'm looking inside and everything looks to be super custom.
Yep.
Custom hot end.
Custom hot end, joint developed with Slice Engineering.
Okay.
And we've got a force gauge in there, so we do nozzle touch right off the bed, meaning you can swap a nozzle, you can change a whole print head out, and you just calibrate again, and you're good to go.
It's moving so fast.
Yes, it's quite quick.
Now, like I said at the beginning, though, you said to shake the machine. Is that right?
Yes, shake the machine. Just don't pull it off the stand that it's on, and we'll be all
terrible.
good.
Well, as long as we're rolling, at least you'll have that.
It will probably still print, to be honest.
Be the memory, right? We'll have to in memorial. Okay.
Rest in peace.
Okay, so just
give her a good shake.
Like shaking is it heavy?
It's not too bad, yeah. Yeah, as long as you're on the table,
you're
good.
I'm on the table.
Yeah, aced it.
Didn't even skip a beat.
No, not even close.
Not even a hint of it.
No, we have actually put a UPS in the bottom of this, stuffed it in a truck while printing, and gone to a customer's place.
I printed while driving.
Yes.
And I could tell that there were imperfections in the print from some of the more non-perfect roads in Seattle that I went over.
Absolutely. We get away with no imperfections there because we're running a floating frame. Everything's mounted to this top plate. So the bed holds plane with the print head, not the ground.
Oh,
so the
really?
whole thing floats. And that's how we get away with the vibration and maintain good wall.
That's cool.
Yes, sir.
Wow, and it's just the servos driving X and Y? How is Z?
Z is stepper motors, and then servos, X, Y, and we've got our own board connecting to the servos from a Duet 3D board.
So I would love to put this machine through its paces, maybe borrow one for a little bit.
Yep.
Since you're so close to me, maybe I drive up, we have a beer, and then I bring one home for a bit.
Oh, perfect. We could work that out. We've got pretty good beer in Vancouver.
I love hearing that, and then I'll print on the way home.
Yeah, exactly. I don't know if we can send you home with enough battery power to get all the way back, but we'll try.
Well, now it's up to you. Everybody viewing this, it looks like I'm going to have a Pantheon machine for a bit in the near future, and I'd love to know what you want to see printed and how you want me to print it. If you want me to print it shaking or upside down or on its side or while driving, everything's up for grabs at this point. Logan, thank you, man.
Thank you so much. Great to finally meet.
You know this, it's a fidget cube, and to print it via FDM, you have to have incredible clearances and command of tolerances to make it so you can fidget with it once it's done. But my friend Kuba here is going to show us the QLS 820 from Nexa and how they printed 500 or more of these in 10 hours.
Yes, exactly. We printed
10 hours.
10 hours, yeah. It's unheard of for this volume and this amount of parts out of SLS technology. And what we did with this build, we packed the job with 65% packing density, which is unheard of for SLS technology. Of course, this is not functional part, it's just a fidget, but it shows that it is possible.
Now 65%, you mean the total build volume of the 820?
Yes.
65% of that build volume was consumed by things that needed to be printed.
By parts, yes.
And in SLS terms, the reason that that's unheard of is because typically when you have that laser sintering, you can't have it sintering so close to other parts, right?
Yes, there's a heat accumulation in the core of the bill, and this heat can leak to the other parts. We try to control this process very diligently, that we don't have this bleeding and overgrowing into the parts, and yeah, that way we were able to achieve that.
Well, now I want to hear more about the machine, because we see this pack, this cake of parts here, and if I come over here, you've got more parts. You've got plenty of parts that were printed on this machine. So what makes you able to do then that sort of job? How come I can do 500 more of these, 65% density in like 10 to 12 hours? What makes that possible?
Yeah, it's a couple of components which stack together. First of all, we decouple the printing process from the cooling process, because with SLS, typically for every hour of printing, you cool for about hour and a half. And we decouple this process by designing this machine in two pieces. So the top piece is a printer with 4 high-power lasers working simultaneously.
Up here.
They live over here, yeah. And this is where we get the speed. So 4 lasers working together give us speed, yeah. And once the print is done, we can immediately take the build unit out. Imagine it's a cartridge for your 2D printer. You run out of ink, and you just swap new cartridge, and you're good to go. And this is exactly what it is.
And that's why it's got a handle, because this just takes out and you wheel it off.
Yes.
And the printer itself with the 4 lasers then is ready to receive another cartridge per se.
Yes.
And you could just go right
You
again.
can just go. Yeah, we believe in concept what's called lights out factory, and this is a very first step to do this. It means like you can print 24 hours, 7 days a week without operator on site.
Without the lights on.
Without lights on, yeah. And the way that we do this is by putting this whole printing platform on AGV, which stands for Autonomous Guided Vehicle. This,
okay.
Yes. This thing has motorized wheels, and it can do it can change the build unit by itself, so you don't have to have operator on second and third shift. You can just schedule the build job, and once the first build job is done and the build unit goes out by itself from the machine, and the next one in line go inside and start the production by itself.
See, that's really cool, because if you imagine automated factory floors, like if you think of an Amazon warehouse, they have all these robots
Exactly.
just going everywhere.
Exactly.
And so now you can borrow that concept, because the printer is detached from the build platform and the cooling. Oh, that's really cool. So then, of course, with the lights out, no one's home, and it just finishes a print, and this just drives off to some area to cool properly.
Yes.
And in the meantime, you still get access to the printer because a new one comes in. And,
Exactly. Yeah.
Oh, that's really cool.
In the future, we plan to have station where it will charge itself with new powder and go back again to the.
Oh, so lights out factory. We're talking. This doesn't just go to a place and cool off where an operator has to then depowder and sandblast and stuff. We're talking about the automation of that as well.
Yes, we have to automate the whole workflow from beginning to the end of the stream of the workflow.
Well, the automation is great. Anytime you think of a future factory, automation is key, and that's kind of where we're heading. And it's really cool to hear about this, because I could just imagine a camera off in some corner just catching robots essentially dancing, and when they're done with their dance, you have usable parts, depowdered, blasted, and ready to go.
Exactly, and you can run those machines from your couch. There is no human interface or like a panel on this thing. We run those machines from our tablets and our phones because it's a web browser applications. You can connect through the VPN to your production floor. You can monitor it on fly. You can see your statistics. We have software which monitor key performance indicators like success rate, errors if there are any, and you can schedule the jobs, and you don't have to be on site. This is future happening right now.
Industrial additive in pajamas.
You call it, I'll borrow that.
Yeah, there you go. The Revo is great. It allows you to change your nozzles easily, and you've seen it before. I really like it, but these are new and allow extended functionality. Can you talk about it?
Yeah, so this is the Obsidian version of the Revo. So the brass nozzle is now a two-part assembly. So the outside is a copper, which allows us to get lots of heat into the material stuff like that. And then the tip is a tool seal. So we're just putting the abrasion resistance right where we need it. And then over the top of all of that, we've got a diamond-like coating, which is basically nano diamonds. So diamonds famously pretty hard, so that adds even more.
Nano is tiny.
Nano is tiny, which is good as well, I think. So yeah, that adds yet more abrasion resistance on top of the tool seal, and then the coating is also really non-stick as well. So particularly in filled materials where you have all the fibers which can kind of like clump up and make little boogers that go into the print, having that non-stick property is really invaluable as well.
That's really interesting. I like the property of non-stick because I don't like boogers when I'm printing either. And that's really interesting that you actually have that insert. So you have tool steel where it matters, but you're keeping copper on the outside for its heat properties.
Yeah, so I guess compared to a brass nozzle, typically with conventional hardened steel nozzles, you'll have to like bump the temperatures 5 degrees, something like that.
Just a little bit.
But by having the copper around the outside now, you can use the same print profile for both the obsidian and a brass nozzle. So if you're printing with PLA one day, you wouldn't necessarily have to change out the nozzle just to tweak the profiles to kind of compensate for the different material, right?
Oh, that's really interesting. Yeah, I've printed with hardened nozzles before, and a bump of 5 or 10 C on the nozzle is usually something that I have to do in order to print properly with it, right? Just because of the properties of the tool steel, but because you have that two-part and you have that hardened steel insert, you don't have to do that.
Yeah, it's a small thing, but it makes it a bit friendlier for the user, right?
Well, that's what this is about, friendly use cases, right? Being able to hand tighten, hand remove, and now you don't even have to change out the nozzle or change your properties, the properties of your slicer profile in order to print properly. It's a lot of P words.
Exactly.
With the obsidian being an insert, and we talked about how it has the tool steel in the middle and the copper on the outside, I just got word now that that is being applied in a different way. And we're talking about a higher flow rate system. So the V6, E3D V6, with typical materials like a PLA, what sort of flow rate will that see?
Yeah, so the flow rate does depend on things like temperature and material you're using, but a V6 is around the 20 mil cubed a second kind of mark.
But now, with this new thing that I'm hearing about, you're utilizing the insert to create a high flow system.
Yeah, so we've taken the stuff we're doing with Obsidian, so insert-based nozzles, and we're making these crazy inserts that have like projections and cross holes and things like that, all to increase surface area and mixing, which allows us to drastically increase the volumetric throughput, but keep the same overall nozzle length. So one day you could be printing with a 0.4 and then change it out for one of these high-flow nozzles, and it will be the same length, but we'll be getting flow rates, again, depending on material and all that stuff, around the 35 mil cubed a second. And that's what we've got so far. It's not quite finished cooking, so we reckon we can get a little bit more out of it than that.
But 35 mil cube per second is a incredible speed.
Yeah,
and you're saying that's not it. Like, this is just so far, but if the cake's not done cooking.
Basically, yeah. So 35 mil cubed a second is significantly more than a volcano for all the other things being, other variables being the same. And yeah, we've only been having that in development for the last, 6 months or so. So yeah, a few more months, I think we can get that significantly higher still.
So in a few months, E3D is going to announce this, and people will get to learn all about it, right?
Yeah.
That's incredible. Hey, Rory, thanks, man.
Thanks, John.
The smallest mosquito ever. Well, smallest mosquito
so far.
So far.
Yeah.
I mean, the little bugs that fly and suck your blood.
They're a little smaller
tiny.
and more annoying.
What am I holding? Come on.
Yeah.
It's so tiny.
It is tiny. So this is called the Mosquito Conduct. It's our latest version of the Mosquito. Conduct, yes, because it conducts heat away from the hot end as opposed to using convection where you would need a fan. So no fan on this hot end.
Okay.
It's designed to be mounted in a heated chamber in an industrial application, and it mounts to a metal plate that has enough surface area to pull all the heat away.
I see. So it sinks away
that heat. And it doesn't necessarily need to have a fan even on that. It just needs to have enough surface area to sort of balance the equation once it reaches thermodynamic equilibrium.
That's
which is
right.
kind of fun.
You don't have to get all the heat away,
Right.
just enough
Just
to
enough.
be at that spot where it likes it, the Goldilocks
Exactly.
zone.
The
right?
Goldilocks zone,
Yeah.
precisely.
So what
Yeah.
application would this serve? Like,
Yeah.
what problem does this solve?
So we invented this because we were working with a customer that was printing PEEK a lot, but then they also had their customers were needing to switch from PEEK and other high temperature materials to lower temperature materials like PLA and PETG, the normal stuff. And what happens if you are trying to do that is when you cool the hot end down to go then switch to a different material, the PEEK or other high temp material crystallizes inside of the hot end. And then if you want to switch to like a PLA, you have to heat it up to the point where it starts melting, and what it can happen is it can clog up the heat break if you're trying to put PLA in it. So
that's no good.
Not good at all. So you get this massive, massive clog, very expensive material, really sucks.
I would imagine this helps enable more functionality within people that are doing high temp and low temp, materials doing, high temp one day, low temp the other day. Because I would imagine clogging issues are a bane to these people's existence.
Huge bane, especially when you're using something like PEEK.
Right.
Very expensive. So that reminds me of a story. We are working with this gentleman named Eric Lamoureux, who 3D prints prosthetics in Guatemala, which is pretty cool.
That is really cool.
Yeah, so he's helping people out for free, and he contacted us because he has a raised 3D machine that he was having to watch all day because it's really hot in Guatemala, and so they were experiencing heat creep issues.
So how did you solve that?
So we solved that with a fun copperhead upgrade for the raised 3D that we sent to him. And he's now able to print 50% faster and doesn't have to watch his machine all night long.
So Eric in Guatemala.
Eric in Guatemala. He's a pirate. Lives on a boat.
Eric the pirate in Guatemala.
Yeah, he's a good pirate.
Is printing on a boat.
Yeah.
Prosthetics. Yeah. To help people for free.
Yeah.
Wow.
It's pretty awesome.
That's actually really
That's
really
incredible.
Awesome.
Yeah.
Does he have an eye patch?
It's awesome. He does not have an eye patch. And no parrot either, but maybe a monkey someday.
Maybe.
Yeah.
We can hope.
We can hope.
Hey man, thanks for letting me come by and see this. I'm at the Impossible Objects booth, and that means I'm here with my own personal god of thunder, Thor.
Hey, thanks for having me,
What's
Joel.
going on, man?
Oh, we're live. We're doing it live.
We're doing it live, that's right.
Yes.
So we recently did an episode where I featured some connectors printed with Impossible Objects technology that held the full Joel. But one of the connectors, or two of the connectors, I'm trying to remember, when they were printed, it was a different model, so this piece right here wasn't as thick, right?
Correct, yeah. Proper model, carbon fiber PEEK, gonna be super strong,
yeah.
Gonna hold the full Joel.
It's gonna hold the, well, in the episode there were comments where people said it was only half the Joel because I had the strap connected to two pieces, and so it splits the weight load. And so now what I need to do is connect both of them up to this and step in.
Yes.
Well, actually, I might make it, I'll put it on my truck, on the tow hitch, and maybe we tow something. We'll see what happens.
The new truck.
But this is awesome. So I will pack this all up nice and safe. I'll take it home, and perhaps in the future, the near future, we'll do a part 2.
Excellent.
That should be fun. Okay,
excellent.
So I got this. Thank you, Thor.
Oh, you're
I really
welcome,
appreciate
Joel.
it. But what's the news? What's the news you want to share?
The CBAM 2, we're adding newest, coolest stuff. So we've been doing a lot of upgrades on the stacking. So increasing your productivity and
stacking, meaning the amount of stuff in a squish.
Yes. So stacking the sheets, but also stacking for the squish. Yes.
Oh, okay. Okay.
So basically, quick recap. We're using sheet lamination process where we're impregnating these carbon fiber sheets with PEEK or nylon 12.
That's right.
Yes.
And then it's impregnated, and then you have the pressure at heat.
At molten temperatures, correct.
And then you get something like this.
End up with this. We do a little bit of archaeology using a sandblaster.
That's right.
And we remove all of the unbound fibers from that carbon fiber block.
I remember at the time I asked how precise it was, and
yes.
I mean, I've got super tiny little mini Joels that were made using that process, so we know that detail could be achieved.
Yes, absolutely. In other news stuff, we are working on a camera system.
That's exciting.
It's so exciting. It makes it so much better for our operators. It's getting to the point where we can just do our normal startup procedures and then be a lot more hands off. It's an AI-based camera system that's going to be identifying issues before the operator even has to, which is awesome. It's so much nicer for us.
Oh, so this is directly impacting your job?
Yes,
and
immediately.
making it better?
Yes, it is so much better now. It's awesome. That, and combined with the new stacker, it's been incredible. Plus, there's been little tweaks and improvements all over the machine to make it more efficient. It's going to be it's just all around better. It's getting
really
better
great
with
to
every
hear.
time. Yes.
So do the cameras produce an image that you can save? Like, are we going to see images from that camera pop up online showing us cool stuff?
Soon, very soon. Yes. So not today, not on this machine, but in Chicago, we do already have a system in place to do exactly that, which is so cool because I can sit at my desk and I could see what's happening on the printers.
That's so cool.
It's so cool
That's
for me,
so
at
cool.
least.
I'm at the Lumafield booth, and I'm here with my friend Eduardo. And why am I holding a Rubik's Cube?
You're holding a Rubik's Cube because we're about to look inside of it.
Now, normally, to look inside of a Rubik's Cube, I put a screwdriver in there and I take it apart.
Yeah, destroy it.
In a violent process that is a little bit kind, but you could do this in a different way.
That's right, yeah. So at Lumafield, we build a non-destructive testing system called an industrial CT scanner. It allows us to look inside of any object without taking it apart, cutting it in half, any of those sorts of problems.
Well, when someone thinks about a CT scanner, they think of hospitals, medical
Right.
facilities, and looking inside the human body.
Exactly.
But you're using a CT scanner to look inside manufactured objects.
That's right, yeah.
Well, we were talking earlier, and someone mentioned that this runs on household power, so I could just
Yeah.
plug this in
That's right.
next to the coffee maker.
You could put this in a conference room or a hallway or a garage or wherever you feel like scanning things.
You said first design principles, is that right?
Yeah.
What does that mean?
Yeah, first principles thinking is where you look at a problem and then you think about what am I allowed to do based on the laws of physics, and you build up from there. So instead of saying what are the components we have to buy off the shelf from vendors that have been making things for 30 years, what could we do if we wanted to do this as cheaply as possible, as accessibly as possible, as easily as possible, without being constrained by the way an industry might work traditionally?
Oh, I see. So okay, typical CT, if we're talking about that, they have the constraint of the human body and the
Sure.
conditions that we can,
That's right.
as humans,
Yeah.
withstand. But when we're talking about objects, obviously the design goes around the constraints there, and
That's right.
because I believe someone mentioned it's higher powered. Is that right?
It's higher powered than a traditional medical scanner, but it's not any higher powered than a traditional industrial CT scanner. They've been industrial CT scanners for a long time.
That makes sense.
They've just been really expensive. So we wanted to bring the cost down substantially and make it much more accessible. In the same way that 3D printing in, say, 2002 was really so expensive that very few engineers had ever used it. Now we're here 20 years later, and it's something that so many people have access to. We want to do the same thing with CT scanning that other companies have done with 3D printing.
That's really cool. It seems like CT scanning would be great because looking inside of something that's manufactured really gives you a better idea of
Yeah.
how it can withstand certain stresses,
That's right.
or how an object might be made better with certain parts added or removed.
Right.
I mean, you've seen all sorts of cases
Yeah,
like that.
you can see interesting things like porosity. You can see electronics. We have these fun little
I
flip
do like,
cards.
yeah, I remember these.
Yeah, you can kind of tilt them back and forth, and here we can see all the insides of the speaker. So you can see if the electronics are soldered correctly, or if there's any potting in the wrong spot, or the wires are in the wrong area. Inside of cast or injection molded parts, you can see if there's any voids or bubbles that form during solidification.
Right.
With 3D printed parts, maybe you care about having a lightweight lattice inside of a part for an aerospace application. How do you know if the middle member of that lattice is solid or not? You'd have to cut the part in half traditionally, but with our technology, you can just look at it and
You have to
inspect
break
it
apart the
directly.
Rubik's Cube.
That's right, exactly.
It's really interesting, though, that you're talking about the price coming down, because it means that, because we've seen a lot of people who are able to do small batch manufacturing, and so this sort of technology, which you've done in reducing the price, allows people who have maybe smaller factories or
That's right.
small run shops
Yep.
to be able to have that quality
Yeah.
control and the ability to look into
That's
what
right.
they make and to offer a better product.
Yeah.
Well, you know what? I have this thing in my hand.
All
I'd
right.
love to see inside
Let's look
of
inside.
it. Can we do this?
Yeah, it's super easy. So just set the object here. This is a bunch of foam.
I was going to say, this is foam,
Yeah, it's
Eduardo.
just
This
foam.
is just foam.
That's foam. That's our magic secret. If you put your Rubik's Cube in the foam, the reason we use foam, just set it right there.
Do I have to mix it up at all?
No, you're good. Well, you could if you want to, but I don't know if we'll be able to solve it with a scan, but we'll see what we can do. The foam is used because it doesn't absorb as many X-rays as the solid object. So whenever we're viewing it,
see.
the foam basically fades away, and then you just see the object. So
I
it
see.
becomes very clear, and that makes it easier to do all the complex math that's needed to reconstruct the object in 3 dimensions. But we'll just look at a 2D X-ray. So come on over here.
Okay. So this is the machine here.
This is the machine.
What's it called?
Yeah, so this is the Neptune CT scanner.
That's a fun name.
We like it a lot. Yeah.
And I've got a Rubik's Cube on your magic foam.
You've got it in the foam.
And-
So all you have to do is set it on that turntable right there.
Okay, here we go.
Yeah. Great. So the next step is to close the door.
That's it, though.
That's it.
Okay.
You're ready to rock.
Oh, it's not that hard.
Not that hard at all. So we latch it in place, and then we get a signal right here. It says X-rays are ready. Everything's safe.
Key is on.
Key is on.
Okay.
We're in a good position. We just hit this button. Our X-rays are turning on. They're going to stabilize.
What does that mean?
It means the X-rays have to warm up. So if you think
Really?
about like an old-fashioned light bulb,
Yeah.
an X-ray source is really just a light bulb. There's a
Oh, I
coil.
guess it is an old technology.
Yeah, there's a coil that's heating up, and then it's shooting electrons out, and those are striking a surface, and that surface emits X-rays. So now, whenever you turn on an X-ray source, it has to heat up, and once we have our preview that's updating here, in just a second we'll be able to see the Rubik's Cube. So we just got to wait a second there. So X-rays are coming in. There we go. That's the inside of the Rubik's Cube.
You can see these are fasteners.
That's right. Those are the screws that are going into these springs, and those hold the things in position. That's what allows you to feel the kind of detents when you're moving. We just have to hit this one button here. It's going to optimize all of the settings for the scanner. It's going to run through a few different exposure settings, gain settings, X-ray power settings, all the different things that make up a really high-quality data set. It'll optimize for this, and then it's going to just start scanning it. Normally that process on an industrial machine, that could take you hours, and it might require someone who has multiple years of specialized training to be able to go in and get the best possible scan. So we're scanning. I just set up all the parameters and it's ready to go. So the way this is set up right now, there's some bars that we can move around. This is estimated to end at 11 o'clock. So it'll be, 45 minutes or something
45 minutes,
like that.
okay.
Yeah,
Gives you time to get a coffee.
Right, exactly.
When people want to know more, where should they go to find out?
Yeah, just go to lumafield.com, or you can Google Lumafield. We're the first results. And from there, it's possible to go in. You can examine a scan library. We have dozens of objects that we've scanned. You can create a free account and explore scans yourself. You can look at, like, on the inside of things like AirPods. You can look at like toys, Pez dispensers, natural objects, all kinds of crazy stuff we have in there. And it's all
really
free.
Cool, man. That's really cool. Well, thanks for letting us take a little look inside of something.
Yeah, thanks for coming by. Appreciate it.
And we're back at the Mosaic booth. As you've seen, we showed off the array. I'm here with my friend, the Element, and it's really exciting to be back here because lots of cool stuff to show you, plus lots of cool stuff at this show, right? What was your favorite part? Let me know down in the comments below. If you've made it this far, you're awesome. Don't forget to hug each other more. See you at the next Rapid. And as always, high five.